Hi. So in this video, we are going to discuss 5 most common methods of probability sampling. And in general, probability sampling is something dealing with randomization. So the idea behind is picking observations randomly, although the techniques might be quite different. So when it comes to most common methods of probability sampling, they are as follows. So we can deal with simple random sampling, stratified random sampling, cluster sampling, systematic sampling, and multistage sampling. So let's start with the very basic one, or simple random sampling. So basically, it can be described as picking the observations from the population randomly. Like you have to design a list of all the observations in your population, and then, for instance, by using some software or any other kind of randomizer, you just pick those observations randomly. As mentioned before, of course, it would require you to draw the complete population list. And because of this, the cost of collecting data might be extremely high. So the obvious advantage of this method is that it is easy to interpret, and here sampling is mostly unbiased. However, on the other hand, it's quite costly in terms of time and material resources, and it might be quite difficult to assure representativeness. So in this case, you kind of imply that it is representative because you pick observations randomly, but there is no way to actually verify this hypothesis about representativeness. Another kind of probability sampling is systematic sampling. And here you can describe it as selecting each nth observation from the population frame. Like you have the list of consumers and you analyze each fifth consumer from this list. Something like this. So in this case, sampling frame is not always necessary, which is obviously an advantage, and it's easier to implement compared to simple random sampling. However, it might be featuring lower level of representativeness compared to simple random sampling. Stratified random sampling is something used more frequently. So basically, this method is about dividing all the observations into subgroups, stratas, that's why it's called stratified random sampling, based on some criteria. And then, after you are done with this initial stage, you can proceed to the stage of randomized selection. So first you divide into some groups and then you go for simple random sampling. You can divide, for instance, the entire group of consumers according to age, gender, or occupation. And typically, you divide your observations into stratas based on categorical variables which are potentially important, determinants of some other phenomena. For instance, you hypothesize that males have different consumption preferences compared to females. That's why you divide into two stratas, which are males and females. You can go for additional stratification if you also hypothesize that age has some effect. So you divide people into 3 subgroups according to age, let's say between 18 and 30, between 30 and 50, and older than 50. And then if you also include gender, you have 6 stratas, and so on and so forth. So here, the obvious advantage is that your sample will include all important subpopulations. So this is how you can make sure that your sample includes people of different gender and different age as well. And thanks to this, it can be more precise. However, the disadvantage is that it might be very difficult to select stratification variables. I mean, this criterion or criteria based on which you actually divide people into subgroups. So here, usually you use some prior theory. So you have some prior evidence about the importance of age or about the importance of gender, and then consequently you divide people into subgroups according to gender and age. However, this is not always the case. That's why sometimes if you go for this sampling method, you might struggle with selecting proper stratification variables. Another option is cluster sampling. So here, similarly to stratified sampling, you divide population into clusters and then you select the final sample using simple random sampling in each cluster. So this type of sampling is usually applied when you have extremely geographically diversified population. So then it might be more convenient for you to split the entire area into some clusters and then pick people or observations from those clusters. For instance, if you want to analyze consumer behavior of Polish people, it might be useful to divide the entire area of Poland into clusters according to voivodeships, for instance. So then you can make sure that your sample includes people from all the voivodeships. So it's typically applied because it's less costly to implement. However, at the same time, it might be imprecise. Finally, we deal with multi-stage sampling, and it can be described as picking the relatively large units randomly and then successively selecting smaller subunits using random sampling. So thanks to that, obviously the process of data collecting might be less costly. I will give you an example. For instance, in Poland, you randomly pick 5 voivodeships. Then, out of those voivodeships, you randomly pick some subregions. Out of those subregions, you randomly pick some smaller towns or cities. And out of those towns and cities, you randomly pick some people. Something like this. So compared to simple random sampling, it's obviously less costly, again, in terms of time and material resources. However, here, it's relatively easy to question representativeness. Because, for instance, you might know that prior to presidential elections, typically, there is some survey conducted by central statistical offices, like for whom you're going to vote. And based on that, they try to compute some, initial primary results of the elections. So if you go for this multi-stage sampling, your result might be biased because typically people from different regions have different political views and different preferences. So here, just by mistake, you can pick the city or town where people are extremely right or extremely left, for instance. So yeah, again, it's applied because it's less costly compared to simple random sampling, but you also have to realize the disadvantage of this method. So that was it when it comes to probability sampling. And in the next video, we are going to discuss some methods of non-probability sampling. Thank you for watching.